Good afternoon. Thank you all for coming. I'd like to introduce you to a talk that I'm personally very excited to see from Mr. John Mad Dog Hall. Enjoy.
Hello? There we go. Okay. A little bit high, perhaps. We'll tune that down. I know. But they said to me that they will take care of that, so I trust in them. Okay? Hello, everybody. It's nice to see you all here. My name is John Mad Dog Hall, or, as they say in China, Ding Gao. And I am the board chair of the Linux Professional Institute. We do certification of open source professionals, and we try and move forward the open source model. We've been doing that for 20 years as of last year, so this is our 21st year. We have 150,000 certified professionals in over 180 countries around the world. My talk is called FOSSH and FOSSDEM, back and forth from the brink of disaster. And I think as I go along, I'll explain a little bit about that title and why it's important. First of all, for the people that don't know me, yes, I am old. I've had 3 heart attacks. I only work with about 50% of my heart capacity. The rest is dead. But that's okay, because I am now the old man moving very slowly in front of you. The person I used to get mad at, get out of the way, you old man. I am now him. If you see me going up and down stairs, please don't hurry me, because that's as fast as I go. But I've had a lot of different jobs in the last 50 years that I've been in computers. And one of the things I'm most proud of is that I am pragmatic. A couple of talks ago, we had some people stand up to say that it is wrong to belittle people who are using proprietary software. And I am happy to say I have never done that to my knowledge. I recommend to people that they should use free software. In fact, I specify free software instead of open source. And you'll see a little bit about that later. Thank you. But I'll give you a warning that this is a highly opinionated talk, and if you wish to disagree with me, we can do it later over beer. So why the brink of disaster? I have seen over the last 50 years things that are going along and seemingly at the very last minute, and typically from some very stubborn people, we have come back from disaster. And that's what a little bit of this talk is about. Now, originally, this talk was supposed to be about the last 20 years, and specifically about what FOSSDEM had contributed to the free and open source marketplace. And I was very happy to do that. And then I received this email from Stephen Goodwin, who is a very nice guy, whose talk is following mine. And he says, "Hi, I think we're talking about the same thing." So then I met with Steve. We worked back and forth, and we came to a conclusion of what I could talk about and what he could talk about. And I heartily recommend that you stay for his talk and listen to that too. And the second thing that happened was reality. Because if I started to talk about all the things that FOSSDEM had done to the level that I wanted to talk about them, we would be here until about midnight. And we wouldn't have time for beer. So that's the reality. And talking about just 20 years of stuff, that's like, trying to leap as far as you can without taking a run, It's a standing broad jump as opposed to a running broad jump. I'm not going to demonstrate this because I probably hurt myself. But that's the way I feel about it. So we're going to take a look in the past with the knowledge of the present, and we're going to do what we should be doing a lot of times, but sometimes we're just too busy. And I'm going to try and show you how we have to be very careful in the future because we may not come back from the brink of disaster. So let's go back into the long past, and I'll try and make this brief, because once upon a time, copyright and patents did not apply to software. When people put out software, there was no license to protect it. We did this under contract law. We would talk to our customers, and we would meet with their lawyers, and our lawyers would meet with their lawyers, and we would have a contract drawn up that said where you could put the software and how many machines you put the software, how many people could use it, so forth and so on. And a lot of times the software was distributed in source code form because there wasn't enough of one type of computer to justify making it into a binary distribution. And the other thing that happened back in those days is when you bought, say, an IBM mainframe, well, it came with the operating system, and there was no real contract that said that. It just did, because you couldn't use the computer really without the operating system, and everybody seemed to be happy with that until one day, a gentleman by the name of George Andal created a computer that was completely compatible with the IBM 360, and nobody ever believed that that could happen. And people could take their IBM operating system and put it on the Andal computer, and it was perfectly happy, except for IBM. They were not happy. And actually, the Andal was a great system because the IBM systems were still water-cooled, and so you needed to put pipes and water and stuff, and the Andal was air-cooled. You didn't need all of that. The IBM had lots of lights and switches and stuff like that on it to control it, and the Andal just had this very large CRT screen that if you toggled the switches right, it would actually put a picture of the lights up on the screen, and it was really cool. And it was cheaper too. And so everybody started buying the Andal, well, not everybody, but a lot of people started buying the Andal and putting the IBM operating system on it, and IBM was suitably distressed. And so out of that came a kind of a legal issue of you need to unbundle your system software from your hardware and allow people to buy it as a separate line item. And this kind of started this whole thing of here's the software, here's the hardware, and never the twain should meet. Now, another thing that came out of the long past, and this really amused me a few years ago when everybody started talking about virtual machines, and VMware came out, and virtualization came every place. I hate to tell you this, folks, but I was using this all the way back in 1968. Because there was this software called CP67, and it was a virtual machine that ran on top of the IBM system, and you could just stop your program or write on any instruction you wanted to. You could kind of like store it away and come back the next day and start it up from that instruction again. It was sweet. And it was called CP67 originally, but then IBM's marketing people got to it and they just renamed it into VM. And the little operating system that ran on top of this virtual machine was called the Cambridge Monitor System because it came out of IBM's Cambridge research facilities. And the marketing people renamed that the Conversational Monitor System. And that became CMS. So VM CMS was really used as long ago as 1968. Likewise, when people talked about containers and stuff like that, I said, I seem to remember this thing called change root. And I was using it in 1979, Now, granted, containers and stuff are much advanced and everything, and it's not the same functionality, but, there's a whole bunch of us that just went around going, okay. And software copyright and patents really started to be applied in the early 1980s. And the thing that started to apply that was actually games. And you could build a game, and in the game it came this little ROM that would actually hold the logic of the game. And people were making clones of those games, and they could clone the hardware fairly well, but they didn't want to do all the work of creating the actual software. So they would just copy the ROM, the ones and zeros inside the ROM. And that was, that was the way they did it. And of course, the game manufacturers that put all the work and sweat into generating those ROMs were upset about that. And they applied to say we should be able to copyright those ROMs and then later on patent other ideas in software and stuff. And the courts agreed with that. And kind of out of that type of licensing and the fact that these systems were being manufactured in larger and larger quantities came the concept of the shrink-wrap software license, and the fact that when you opened up the package, you accepted whatever abominable terms were in those tiny little smudge-like writings of them. And of course, there's a whole bunch of people who objected to this. One of those was Richard Stallman, created the free software movement. But in a lot of ways, the free software movement already existed. There were people who exchanged software, worked together with source code back and forth. This was nothing new. In fact, it was proprietary software that was the new thing on the block. The free software was just a continuation of something that already existed. And, of course, you're aware of the fact that Richard Stallman wanted to create the entire operating system that he called GNU. And in 1985, he created the Free Software Foundation. Now, here's the first brink of disaster thing. What if he had said simply, it's not the Free Software Foundation, but it's the Freedom Software Foundation? Just think about how much easier that would have made it on all of us. That tiny little slip, that tiny little mistake made it so, no, software libre, and all this stuff, and it's free software, I don't have to pay for it. No, it's freedom software, idiot. That's the most important thing. And then he invented the GPL, which people laughingly called copyleft. Now, Richard and I disagree on a couple things. Yeah, we do. One of the things we disagree on is the concept of, is there intellectual property? And I personally believe that there is intellectual property. I believe that when you write something or you create something or you do something, that you should have the right to say what happens to that. And that you should be able to protect that intellectual property either through copyright or patent or some other legal means. And, and because without copyright, then every single license you generate actually has no meaning whatsoever. Because without copyright, your software is in the public domain. And so Richard would continually badmouth the concept of copyright. And I would say, well, Richard, if you didn't have copyright, then your license wouldn't make any difference. Blah, 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 blah. But I consider that a small thing, really. It did create some friction between us. And then, of course, we also had all the non-free software that was coming up, and CPM, and people never talk about poor CPM anymore. But CPM was my real exposure to the bizarre world of shrink-wrap software. And MS-DOS and that Apple company, and other proprietary systems, and we don't talk about those that much anymore either. MVS, VMS, HPUX, all the proprietary operating systems and Unix systems, some of which did work around standards. Now, I want to say one thing about standards, and Ken Olsen, who was the president of Digital Equipment Corporation, famously said one time, standards are as interesting as a Russian truck. And the press dragged him over the coals for that. And I thought that that was rather bizarre that he would say that, because digital spent a huge amount of money in standards work, in working with people to create standards. And when I finally caught Ken one day and I asked him about that, I said, Ken, why did you say that? He goes, he says, that's just a personal thing. I'm an engineer. He says, and I have to work on a standards body, and those nitpicky little standards people, they pick on this and they pick on that, and I hate that stuff. But once the standard is created, it's my job to implement software to that standard, to make it fast, to make it small, to make it robust, to make it secure. That's what I like doing. And I said, thank you, sir. Thank you for clarifying that. And that's what standards are really about. Because if we didn't have standards, the pipes in your buildings wouldn't fit together, and the electrical components in your computers wouldn't work. And standards are very important. Open source and free software started to come about, and projects that no longer exist, like MIT's Project Athena, which gave us the X Windows system, and Kerberos for network security. BSD, which fortunately does still exist, but it's not just BSD, the operating system itself. It's interesting that the term BSD is not just Unix. It's the Berkeley software distribution, and they created a lot of software other than just Unix that they distributed. I had a PyDP11 with me at the LPI booth this week, and people came along and started talking about it, and then we got to talk about BSD and all of the work that went into that and the history of it, and it was wonderful. People think it's weird, they say, hey, Mad Dog, you're a Linux person. And I am a Linux person, but before that I was a Unix person, and I worked with BSD and other Unix systems. And the other software that we hardly ever talk about, software like SendMail, EXVI, and software that came from the BSD distribution and passed out onto other distributions of other operating systems. In fact, I point out to people that if Richard Stallman, when he started the Free Software Foundation, had concentrated on the kernel first, he might have worked on that kernel for 2 or 3 years, and at the end of that development, he would have no applications for it. And by the time the applications came around, that kernel would be useless. So instead, he concentrated on applications that run across different operating systems and compilers that went across different hardware platforms to make it so that people like you could develop applications that were widely available to the greatest number of people. And out of that creation of that software, there was lots of little companies that all of a sudden came into existence, companies we may not remember anymore, but the Ingress company that supported the Ingress database engine that started at the University of California, Berkeley by Michael Stonebreaker. And Michael left the university and went and formed a company that gave support to the Ingress system. And Ingress still stayed as free. You could still pull the university Ingress system down and use it. But if you wanted to get support, you could get it from Stonebreaker's company. Out of that, eventually, was Postgres. Michael went back to the university again, started the Postgres program, and the same thing happened. Very good free software mechanism. Cygnus, who took the GNU compilers and created a support system. Cygnus was great. I loved the company because the board of directors would meet at a hot tub out in Palo Alto, to have board meetings. I like that type of a company. Matt, we have to do that sometime. And it's companies like Primetime Software and Walnut Creek, and another little company called Young Minds, who distributed software. Now here's another edge of disaster story. Because once upon a time, software was distributed on magnetic tape. The tape drives were pretty expensive. The tapes were expensive. I remember a TK50 tape from Digital Equipment Corporation was $100 US back in 1989, 100 US dollars, and it held 95 megabytes of data. And because it was a tape, and because it was linear, you couldn't really have something like a live file system on it. And I, at Digital, wanted to see software distributed on CD-ROM. And I had a lot of my management laugh at me because CD-ROMs, oh, those are for the music stuff. Yeah, music. And so I said, no, I think that we should put digital data on there too, computer data. So the standards bodies were working towards a standard, an ECMA standard, for the placement of the file system on a CD-ROM. And one day I got a call from a guy at a company called Young Minds. He said, Mad Dog, we have a problem. I said, what's the problem? He says, well, the standard for CD-ROMs is going to allow for 4 levels of directory structure and file names that would have 8 characters before the dot and 3 characters after the dot, and no symbolic links. I said, really? That's kind of bad for Unix, isn't it? He says, yes. He says, the reason that standard is coming, though, is because the 2 major drivers of that standard are DEX VMS system, which, by the way, used file names of 8 characters and 3, and Microsoft with MS-DOS. I said, I see the problem. I said, he says, we have a fix for this. It's called the Rockridge standards, but they're not going to put those. They're optional standards. They're not going to put those into the ECMA standard. And I said, oh, well, who's working on this? Who can I contact? He says, there's a guy at DEC who's the editor of the standard. I said, really? What's his name? And he told me the person's name, and I said, that guy only sits a cubicle away from me. I'll go have a talk with him. And to make a long story short, I blackmailed him into putting those standards in. As a side note, and a somewhat sadder note, a young engineer was working with me to implement those extensions in one of our distributions of Unix. And we had to trick our management into letting us put that in one of our releases. And that engineer was a very great engineer who unfortunately died at a very early age, the age of 30. His name was Paul Shaughnessy. And it was because of Paul Shaughnessy that Digital got an early distribution of the ECMA standard ISO 9660 with the Rockridge extensions. So, and then as time moved on, there was lots of almost there solutions. The Berkeley software distribution created us a different distribution than AT&T. Now, why did a lot of the different companies like Sun Microsystems, Digital, Hewlett-Packard, all decide to use the Berkeley distribution instead of the AT&T distribution? Well, for one thing, the Berkeley distribution had demand page virtual memory. And the AT&T distribution of that time only had a swapping system. The Berkeley system had the fast file system from Berkeley. And the System 5 system still had a rather weak and miserable file system there. I mean, things changed. It got better. But at that time, at the time the decision was being made, these are the decision factors. So a lot of the companies went with a Berkeley distribution at that point. And then sometime later on, as an example, Sun Microsystems went from Sun OS, that was based on Berkeley, to Slolaris, that was based on System 5. Now, to be fair, the System 5 code at that point was mostly a research type of system, and therefore was never really tuned to be efficient. Versus the Sun engineers had spent a huge amount of time tuning Sun OS to be even more efficient than it was from the Berkeley people. And when they got the source code for System 5, they went, oh my God, this is terrible. But their management pushed them to put it out. And so I called that release, the Sun OS to Solaris, I think it was Solaris 3, I called that the all pain, no gain port. Another thing that happened about that time was a suit against BSDI, because there's this little company that said, hey, we can give you an entire Unix system with the source code for $1,000 per machine. And this was a really great deal, because if you wanted the source code from AT&T, the license at that time was $160,000 per machine. Oh, that wasn't the worst part. The worst part was that you had to tell them the serial number of the machine that you were going to put the code on. Now, how many of you know the serial number of your laptop? Oh, one person raised their hand. That's good. The rest of you are slackers. And if that machine broke, you had to find the person at AT&T who was giving out the licenses, and you had to tell them, oh, I'm taking it off of serial number and I'm putting it on serial number before you could do that. That was a nasty thing to have to do. But BSDI didn't care about that. You paid them $1,000. Here's the source code. Put it on your machine. Unfortunately, AT&T took a little bit of being nasty about this, and they sued BSDI, and this became the first really horrible suit of AT&T versus everybody else in the world with Unix. And that dragged on forever. And finally, it was settled in 1993. And when that was settled, and with some work by Berkeley, because Berkeley, as soon as this started to happen, they said, we're going to rewrite all the code. There's not going to be a single line of AT&T code left in our distribution. And Keith Bostic, he should be sated, okay? Keith Bostic led this effort, and all the people, and I think it eventually came down and there was only like 17 files that had anything that looked like AT&T code in it. And Keith said, oh, that's easy. We'll rewrite the 17 files. And out of that came BSD Lite, which generated NetBSD, FreeBSD, and then later on, OpenBSD. But even with that, Unix was losing, because all of the vendors, all the major vendors had ceded the desktop to Microsoft. The vendors said, oh, we'll sell server systems, and then people could just use MS-DOS on the desktop, and then it came along Windows NT. And then all of a sudden, the vendor said, oh my goodness, they don't want just a desktop, they want everything. And that's when they started to panic. And even Tim O'Reilly has stopped selling Unix books. Well, maybe he stopped selling them, but he didn't develop any new ones. He started developing Windows NT books and programming books and stuff like that, because he said, I have to keep my business alive. I employ people. I have to keep them alive. And I don't blame him for that, because if you go bankrupt, that's the opposite of making profit. A lot of people in the free software space, they say, oh, they're charging money for that, as if that's a crime. Even Richard Stallman says you should be able to make money with free software, because the opposite of making money is going bankrupt, and then everybody loses out. So that was a really bad part. And then along came this other thing, the Linux kernel. Because the GNU people had everything, well, not everything. They had a lot of stuff. And we took stuff from Berkeley, we took stuff from just the free software space in general, and we mashed it all together to create these distributions. Unfortunately, some that are no longer with us, soft landing systems, Yggdrasil, that's how you say it, by the way. Debian, fortunately, Debian's still with us. Red Hat, Slackware, and others. And a lot of other distributions. But the really thing that really got to me was the media love of Linus Torvalds and the free software movement. And I know that for a long time, the BSD people were really incensed about this because they said, hey, we have a better TCP/IP stack. We have better this and better that. And I would say, yeah, you probably do. But you guys have a demon as an emblem. We have a cute little penguin. You guys, and I'm not, I've always looked scruffy, so I'm not a person to talk about this, but hey, quite frankly, a lot of the BSD people at that time had big beards and long hair and stuff like that, and here we had this nice, clean-cut young man with sandy brown hair, wire-rimmed glasses, that wore wool socks and sandals, and spoke perfect English with this lilting European accent. Hello. I'm Linus Torvalds, and I pronounce Linux as Linux. Linus eventually left Helsinki, Finland, and came to the United States to work for Transmeta. And I called up Transmeta one day looking for him, and this voice on the other end of the phone says, hello, this is Linus. I said, Linus, that isn't even your name. He goes, I know, but nobody in California can say Linus, so I'm Linus. And that just endeared him to me because there would be so many people that would just spend the next hour on you. I'm Linus. He didn't care. He famously one time says, I don't care what you call the operating system as long as you use it. So here's your chance, BSD people. You should just call Linux BSD. So, Linux version 1.0 came out in 1994. That's when I first really saw Linux and understood about it. And I met him and gave him an alpha system so he could make it 64-bit and also get the Intel-isms out of it, make it more portable. But from a Unix standpoint, it was still a weak, miserable system because it didn't have symmetrical multiprocessing, it didn't have failover, it didn't have, it had a relatively fragile file system, all these different things. And so, but we had lots of distributions that kept going on all the time. But the other thing it didn't have was applications. I mean, sure, it had all the little commands and stuff like that. And yes, there were some, other free software that ran on top of it, but the type of commercial applications that sells a distribution or a computer system did not exist. So I brought out about 5 or 6 different operating system hardware combinations in my life, commercial systems. And the first thing you do is you release your system, and then you go out and you try and get application people to put their applications on it. And you go up to them and you say, hi, I'd like Mentor Graphics. I'll just use them as an example. Mentor Graphics, would you port your code to our system? Well, I'm sorry. You don't have the compilers we need. You don't have the debuggers we need. You don't have this, you don't have that. But then you say to them, well, but we're shipping 10,000 a day. Oh, just kidding. It's running out in the lab. We can have it next week. Because the only thing that gets an application vendor to port to your system is volume. They'll tell you all sorts of other reasons, but it's volume. And if you can say to them, we're going to have millions of systems out there, they'll do the port no matter how difficult it is. Because they do the little calculation in their mind. They're shipping 1 million systems a month. I'll get 5% of those systems. Oh, my God. Oh, my heart be still. That's lots of systems. So applications, or lack of them, was one of the problems. But we had this great thing happening because there were these wonderful people called ISPs, Internet Service Providers. And they were already providing machines and stuff for people to log into with shell accounts and stuff. And these machines were almost invariably based on Spark and Solaris. And they found out very quickly that for about 30% of the price, they could do the same thing with Intel and Linux. And so a big market of sun just went pew out from underneath of them. And then along the way, there was this wonderful concept of LAMP, Linux, Apache, MySQL, and Perl or Python, whichever you wanted. I could have even thrown in Pascal there if you wanted it, but... And it was a nice algorithm, LAMP. Everybody loves a lamp. You go into a dark room, you turn on a lamp. You can't miss with that. It's marketing. It's all marketing, right? And so thank you, Tim Berners-Lee, wherever you are, for coming up with the World Wide Web, because it was just great. And we found out that we could reuse old systems, for more than just a doorstop. We could use them for firewalls, DNS servers, all these things that we didn't want to dedicate a newer, more costly machine to. And so when we bringing in 486s, we could use the old 386s. When we're bringing in 586s, we do the old 486s. And people liked this. They didn't like a certain company in Redmond, Washington coming along and saying, we realize that 5 million people are still using XP, but we're not going to give you any patches anymore. And if you have to, and you have to upgrade to Windows 7 or Windows 10 or Windows 2000 or Windows Me or Windows U or something like that, in order to keep using your old hardware, well, gee whiz, it doesn't run on that either. And so you have a doorstop. But we could use this new Linux system to make use of those old systems. And speaking of reusing, in 1995, a very interesting thing happened. The supercomputer market was going out of business. Cray, ECL, Cyber, the CDC Cybers were all going out of business because they would spend millions of dollars in designing these new machines, and then they would sell 5 of them. One of them to the agencies, so we dare not say their name, and you know who they are. And then 4 to universities that couldn't pay for them anyway. And these companies were going out of business, and 2 people, Dr. Thomas Sterling and Donald Becker of NASA, implemented this concept that became known as Beowulf supercomputers. Now, I was somewhat distressed today that at breakfast I was talking about this, and there was somebody that didn't know what a Beowulf supercomputer was. Be still my heart. Because these were great. They could use commodity systems to implement a distributed cluster that could solve very important problems. And probably the most important problem, and that includes today, it's even more important today than it was in 1995, is this problem called fluid dynamics. Because fluid dynamics is every place, even with things that we don't think of as being fluid. I mean, we think of this as being solid, and it is. But the heat passing through this is fluid. And we need to be able to track that heat. Water, air, the environment, everything is fluid dynamics. And we need to solve these problems. And it gave them the ability to solve these problems 40 times cheaper. Or, looking another way, with the same amount of money, you could buy 40 times the computing power. But the great thing about this for Linux was that most of these applications were not something you bought in shrink wrap down at the store. How many of you have gone down to your PC store and seen the box of supercomputer software shrink wrapped up, $29.95? Actually, it did exist. Red Hat, one time, made a CD-ROM. They called it the Extreme Linux CD-ROM for rocket scientists. And they thought they were only going to sell like 100 of these. And they sold thousands of them. Most of them were never taken out of the shrink wrap. People just wanted to buy it and stick it on the shelf so they could say they had supercomputer software on their shelf. And today, there are still people trying to make supercomputers out of the Raspberry Pi Zero. Never mind the fact that the poor Raspberry Pi Zero is going to use all of the CPU power just sending the data from one to the other and have nothing left over at actually solving the real problem. In 1997 to 1999, there was a series of things that started to spring up. Slashdot, SourceForge, ThinkGeek. Now here's another almost disaster happened. I had a friend of mine who was working for VA Systems, and he told me, he was just like an intern there, and he told me that he was thinking about going to West Point. Oh dear. I just saw 10 minutes left. I'm on slide 19 of 157. He said, I'm thinking about going to West Point. I said, well, that's very nice, but I was thinking in my mind, this kid's going to go to West Point. He's going to end up in some military, no, actually, it was the Naval Academy. He's going to end up in some ship, and he's going to be sunk, and we're going to just lose this great programmer. And I said, Drew, I don't think you should. I think you can give back more to your country by being a good free software developer than going to the Naval Academy. And he thought about that for a little bit. He decided not to go. And it was Drew Stribe who came up with the concept for SourceForge and implemented it. So I am guilty of taking away a great naval officer. On the other hand, I am guilty of helping to give SourceForge. In 1995, Patrick de Cruz from Australia decided we needed a organization to try and promote the business side of Linux. And so he started Linux International, and the first president of that was Alan Feder. After about 6 months, Alan said, I need a job that pays real money, so he left and I took over. I was being paid by DEC, and so I could do the job for free to help the Linux community. And one of the first things we had to do was to protect the Linux trademark from a guy named Bill Delacroce in Boston, who had trademarked the term Linux and was holding it for ransom. And so we jerked it away from him and gave it to Linus and created the Linux Mark Institute to protect it for all time. We also started the Linux Standard Base project that was started by Bruce Perens. After about a month, people realized that Bruce wasn't the person to lead that. And Jim Zemlin actually took over and took the Linux Standard Base project forward. We realized we needed certification. And we helped to promote 2 different certification methods. One of them was SARE and one of them was LPI. SARE was a for-profit that combined teaching with a certification. LPI said we feel that people should be able to get teaching or education any way they want to. We only do certification. SARE eventually failed. LPI went forward and is still going strong. And we supported early Linux marketing events. In 1998, database support came in, with Informix being the first database to actually support Linux, and Oracle coming about 9 months later. But they found out about the Informix announcement, and they hurried up their announcement 2 days before, taking some of the wins out of Informix. More side events: Sun buys MySQL, 2008, and then Oracle buys Sun. Yeah, okay. In 1998, the open source term was coined. I am one of the people credited for the term open source. It really wasn't me. I was in on the meeting, but I left to go to the bathroom, and by the time I came back, it was too late. But it did recognize that all these different licenses, some of which were competing with each other and incompatible with each other, we needed to cut down on that. And some people didn't like open source, and there was one particular person that didn't like the term free software because they considered the GPL a virus. We'll see more about them later. The dot-com boom really got underway in 1999. It burst in 2000. And a lot of the things that we love and dear were in danger of going away. But they managed to survive right before the dot-com bust. The IPO of Red Hat, one of the most successful IPOs of all time, and VA Linux Systems, that was definitely successful as an IPO, even though the president of the company admitted to me he didn't really have a business plan. Sun Microsystems became open, and IBM invested $1 billion in Linux. And the next year, they recovered that, which was a big shot in the arm for Linux systems. Open Source Development Labs, OSDL, was created in 2000. They were started to help developers get access to hardware, because even though developers could have a PC on their desk or something, when you're trying to put an IBM mainframe underneath your desk, it's difficult. And they hired Linus Torvalds and paid him a salary, and he hired other people. But unfortunately, they were on the verge of bankruptcy in 2007. They were reorganized as the Linux Foundation under Jim Zemlin, and have been fairly successful since then. Of course, FOSSDEM was created in 2000, but it was actually OSDEM at first and became FOSSDEM the next year. We'll hear more about that later. And free and open source developers came in. So these are some of the interesting events from the year 2000 to year 2020, embedded systems. In the year 2000, Linux became the most used operating system in embedded system design starts. Why? Because up until that point, everybody wrote their own operating system for embedded systems. But then a very strange thing happened in 2000. The customers started to say, I want my embedded system to talk to the internet. Oh, by the way, I want to use all these little chips that are really neat. And the embedded system people said, TCP/IP stacks are hard. Security is even harder. And we don't support all those chips. We only support one. Oh, my God, there's this operating system called Linux that does all this. And so, they went over to Linux. Canopix came out. September 30th, 2000. Very interesting operating system. It's a live operating system. Klaus is a very great guy. Really love him. FreeBSD jails were in 2000 because they could. And so people started using FreeBSD jails to be able to isolate various pieces. Steve Ballmer said that Linux is a cancer, June 1st, 2001. In 2003 to 2007, there was a lawsuit of SCO against Linux and IBM. Very famous lawsuit. How many people remember that? Who doesn't remember that? I want to take the time right here and right now to tell you that that was the evil SCO that did that. That was actually Caldera, who had bought SCO from the good SCO guys. And it was the evil SCO guys that did that. The good SCO guys were Doug and Larry Michaels, who started Santa Cruz operations, created a really nice little Unix distribution, and they were going to sell SCO and start a company called Terratella. And the reason that I was telling you that these guys were good guys was because in 1997, Doug Michaels insisted that Linus Torvalds get a lifetime appreciation award in 1990 at the tender age of 27. I was 47 years old. I hadn't got a lifetime appreciation award. And here's this guy getting a lifetime appreciation award. And Doug insisted on taking Linus to breakfast the morning of the award and talking with him. And afterwards, Linus came back and I said, Linus, what did he say to you? And Linus says, I was so embarrassed because he asked me, how could SCO help Linux Ubuntu started in 2004, creating great desktop distribution. Android started in 2008. And then there was the VMs coming out of different types, KVM, Zen, and different ones. And then the cloud started coming. And these are things that are just kind of interesting to me, okay? The Raspberry Pi shipped in 2011. And then we had containers of different types show up, Docker and Kubernetes and others. I got interested in FPGAs. Linus has said if he wasn't going to start an operating system again, he probably would start studying FPGAs. And RISC-V. I'm very interested in RISC-V. About that time, I had a friend working for a consulting company. His name was Jonathan Eunice. The company was called Illuminata. Unlike a lot of people who are analysts, Jonathan was a technical analyst. He looked at the technical abilities of different operating systems, and he specialized in Unix. So we compare Sun OS to Solaris to Digital Unix to Ultrix to all these. And I asked him, when I first started working with Linux, I said, Jonathan, what do you think of Linux? He says, Linux is a toy. A couple years later, I said, what do you think of Linux? He says, Linux is getting interesting. I asked him a couple years later, he says, I recommend Linux for non-critical applications to my customers. And finally, I was at an enterprise meeting down in Washington, D.C. with the government, education, business. And Jonathan was a keynote speaker. And I got up at the end of his talk. I said, Jonathan, and I recited all these things he had said to me in the past. I said, Jonathan, what do you think of Linux now? He says, I recommend it. I recommend to all my customers that they at least consider it for every application. That was a long way to come in just a short time. But when I was leaving digital in 1999, the day I was leaving, my senior manager took me down to the cafeteria and very quietly asked me the question, when can I fire all of my DEC Unix engineers? When will Linux have the functionality necessary to support our customers and I can migrate them off of Digital Unix onto Linux? I told him that I couldn't give him the exact date, but it was going to happen. So why open? Open gives all of you people the ability to get the code and know that you can put it into your products, the things that you are making. But most open licenses do not force you to give your changes to the end user or even back to the open system. Why freedom software? Because freedom software gives you the same capabilities of getting the software and knowing what you can do with it, but it also allows the end user to have access to those changes. I have an entire drawer full of calculators and small computers that I cannot use anymore because the software that went into them was not free software. And people say, well, most users don't have the expertise to fix it, and that is true. But they don't have the chance of fixing it. They can't make the decision to make the investment to fix it. They can't join with a group of people. If the 100,000 XP users had gotten together with a group and said, we want to fund patches to XP, if they'd had the source code for XP, they could have done that. They might have been able to find one Microsoft engineer that could code. And so, what are the new challenges that we as a group have? We have to decide who really owns free software. Do we own free software? Oh, I'm sorry, I went back. Do we own free software? Do the companies own free software? Does the community own free software? Do end users own free software? Or is it all of the above? Nobody owns free software because we all own free software. And that is why I like free software over open source. And what worries me is that some companies who say they love open source are creating closed solutions with open source. And there's been a lot of people in this track who have talked about that today, not just me. And the other thing that worries me is we have 95% of the people who are now using open source and some that are using free software that don't value that freedom and they don't care whether they have it or not, and that's a problem. So we have new challenges and opportunities. These are the major ones, I think. Security and privacy. It's worse than most people understand. One of the reasons I'm interested in RISC-V is because I want to create a completely open chip with a completely open BIOS, with completely open device drivers, with completely open software, with completely open applications, chained with a chain of trust up it. And those processors, you should be able to look at the mask for those processors and be able to say, yes, this is free of trapdoors. It's free of malware. We should be able to have clouds in our own home from the cloud software. That if you want to use clouds from a company, you can, but we should be able to use the same software in our own homes. We need ease of use that is so intense that even my mother and father should be able to use it. I wrote a white paper in 1986 talking about my mother and father and electronic things. If it had more than 2 buttons on it, they were lost. They would not be able to survive without their tech guy. It's funny. Tuve Torvalds, every time she talks about Linus, she calls him the IT guy. Yesterday, the IT guy's father showed up here. Literally. And it was nice to see him again. Artificial intelligence. All the people out there that talk about artificial intelligence, please stop calling it that. You should call it inorganic intelligence, because there's nothing that is going to limit artificial intelligence. I believe in the Alan Turing model of artificial intelligence that says that our brains are made up of synapses and neurons. It's a chemical, electrochemical reaction, and if we could duplicate that with silicon, we can have systems as intelligent as us, and there's nothing that's going to stop that. Be very afraid. Money versus the community. One of the problems with free software is we typically don't generate enough money with free software to put lots of ads on TV. Education with FOSS, we're still not doing the right education. I think I'm out of time, but the fight is not over. We need to fight. Love is love. I got in a problem with that last year. I'm not going to go into how you should act in the shower. But we should love free software. And we should be aware that some entities that were using free software are now going back to proprietary software. But one of the things that drives me forward, and I really love this, and it's happened here, I hope it continues to happen, is when the people come up to me and say, I listened to you 10 years ago, 20 years ago, 30 years ago, 40 years ago, and now I own my own company, or I employ 60 people, or I've created this free software project that 10 million people are using. It's because I listened to you. Thank you. And now I say, thank you. Thank you. Thank the people at FOSSDEM.